Okay.
I go? Perfect. Okay. Hello, everybody. Welcome to our next session, Landscape Terrain Modeling. The session will be moderated by Dr. Nano Langham here, lecturer in landscape architecture and urban design here at the MSD at the University of Melbourne, and it will also be moderated by Thomas Chapman, National CAD Manager, Senior Landscape Architect at Realm Studios, both of them obviously in person, and we will be joined by Professor Peter Peschke from OST University of Applied Sciences in Switzerland, who will be joining us online. And I'll pass it to Nano to introduce your keynote speaker in more detail, but thank you very much.
Thank you, Larry. Thank you. I'd like to acknowledge the custodians of the land on which we're meeting today, and I'd like to pay my respects to elders past, present and emerging, and to the way they sustainably managed land for the past thousands of years. So this session continues to think about sustainable land practices with a particular focus on how we design with topography. One of the most critical aspects of the practice of landscape architecture is working with gradients, soil properties and drainage for that top 500 millimetres of soil. While development of topographic manipulation skills is seen as one of the least glamorous and most challenging aspects of learning to be a landscape architect, it is the single most important skill set we bring to the table for addressing critical contemporary issues of social equity and impacts of climate change. 1 in 5 people are part of the disability community in Australia, which includes a growing number of people with different levels of mobility. So thinking about the environment, not just inside buildings, but on footpaths and through parks, has an immense impact on people's lives, how they get to things, and even if they can get to things. If you've spent time in a wheelchair, you'll know the challenges of navigating outdoor environments using footpaths designed to drain rainfall into waterways as quickly as possible, and it's something that we know now wasn't a great strategy for the health of waterways either. On the impacts of climate change front, the remit of landscape architects involves working with overland flow systems to manage and moderate flood from increasingly flashy and more intense storms, implementing stormwater infrastructure into streets, parks and footpaths. Grading and drainage has traditionally been a hand-drawn, hand-calculated skill. Over the past 2 decades, we've been transitioning to computational methods of practice, and we're very lucky today to have 2 leaders in the field with us to discuss their work. Professor Peter Peschke joins us from OST, University of Applied Sciences in Rapperswil, Switzerland. Peter has been at the vanguard of digital grading for landscape architects, publishing several important textbooks translated from German into English and Chinese. And Thomas joins us from Melbourne and is a computational landscape architect who writes open source tools to assist landscape architects with streamlining modifications to digital terrain models. We will have a presentation from both these leaders in the field, and that will be followed with some time for questions. So it'd be great to start with Peter, I think, if we can.
So I'm ready. Can I start?
Yes, thank you.
Hello, everybody. Greetings from Zurich, Switzerland. Great honor to be in this conference. I was told I have 20 minutes, so I better get started. So I switched to my PowerPoint presentation. And I will, the only thing is, okay, somebody has to tell me when I reach or Nano, if you could tell me when I reach the 20 minutes. I just thought I could see my watch at the bottom and I don't see it, so please tell me 5 minutes before the end of my time. So let's get started. digital grading, that's a topic I'm dealing with for almost most of the time of my professional and teaching career. And the next step in Switzerland will be BIM for rainwater management. In summertime, unfortunately, the summer is ending now in Zurich. In the last summer, there were a lot of articles about heat islands, the problem of heat, and also the topic of sponge cities. So the public is becoming really aware of the topic rainwater and heat. So two things we can do as landscape architects. The first thing, we need to plant more trees. We have to create shade, shadow in the cities. And the second thing is we need to deal with grading for rainwater management. There's a great textbook I used as a student in the US, Grade Easy by Richard Unterman. It's in the public library. Please check it out. And my book is a little bit more technical, more dealing with the digital topics. And Richard Unterman and me were not the first who dealt with grading. The first published book or plan on grading is by Adolphe Alphon. That's a park, Butte-Chaumont in Paris, completely done with grading, and the plan are published. And it's a good example how a project with a lot of topics like infrastructure, etc., is taken on by with the help of analog grading at that time. So also this book is available on the free library. With grading, we can do great things. We can guide the rainwater. You all know about that, so I don't need to show you a lot of good examples. Also, in terms of terminologies, there are a lot of terminologies out there. I prefer sponge city and rainwater. And what we don't want to have happen is these type of errors. And also in terms of trees, we don't want to have this type of temporary trees. I really feel ashamed. This is an example outside of one of our campuses, and I think that's not the way to go. Thanks to BIM, we should simulate and create spaces for our vegetation permanently, and we must have more trees around our buildings in our cities. So what's happening in Switzerland? The Swiss government decided 2016, whole Switzerland has to become digital. And therefore, also the topic of building information was pushed by the Engineering and Architecture Association. There's a guideline out. And the really good thing is the guideline is not only covering architecture and buildings, but also the landscape and landscape architecture. So now all the public owned companies have to follow the BIM process from 2024. So there is a big company called a train company, which only is a big mover in terms of housing, and they will use the BIM process starting from 2024 in all projects. So let's get started. How would a project then look like? We have no data. We have all these different steps, and I will cover a couple more in detail. So let's get started with the data topic. We need data. We need terrain models. In Switzerland, we have the advantage that all the data, all the digital data, the terrain models are super precise, around 2 meters resolution, 50 centimeters in terms of aerial photos, and all the data is available for free for the public, also for commercial projects. In case in your country this is not this is not possible, make sure you check all the GIS data. We need a basis for terrain modeling. And I will cover first the topic of data output. We want to build projects, so our data eventually has to end up on machines. And this slide shows the topic of global navigation satellite systems, how it works, and what is the advantage of GNSS-controlled machines. No stakeout is any longer necessary, and your data directly, your terrain models can directly be manipulated in the field. So let me quickly show a video, and I will, as I don't have that much time, I will stop in the middle because I think you get the point. Lam, the sound is working, right? So in case you don't have terrain data, drones would be an option. And the photogrammetric process of creating a terrain from photos is really advanced and well developed. So use this type of methodology for creating your terrains. And we want to send the data on the machines. These are our robots. In architecture, you have this robotic systems. In landscape architecture, we have the diggers and dozers. And they are controlled by satellites. They always have these two satellites, antennas. They can do a really precise job. And as you can see here inside the dozer, you have the terrain and you can precisely control the machine with your terrain data. But for doing that, you need a digital terrain model, which then can be used by the machine. I think, yeah, you see again how the machine is using directly my terrain data. So I think I can stop at that point and carry on. And this is already reality also in landscape construction in Switzerland. This person, young person, he's a former student of mine. He's an owner of a landscape construction company, and they won the bid for a highway. Highway was put in a tunnel, and they did all the terrain grading for about 1 kilometer with a dozer. They leased the dozer, a GNSS dozer. The terrain data was developed by the landscape architects. And so the landscape contractor was able to use the terrain data for modeling this landscape in order to become a park. Also, in terms of if there is a smaller project, there are great developments in terms of robotic stations. And BIM to Field is also arriving the landscape architecture education. Let me quickly show again parts of a movie. And
in landscape architecture, we often need height information below the tree and shrub layer. To get the information we need, we use a mobile handheld laser scanner in our training.
Das neu konzipierte Modul.
The newly designed BIM to Field module aims to show students a continuous workflow in dealing with digital data. The students then use the digital terrain model as a basis for creating a project. The completed project is then uploaded to the BIM 360 Data Exchange platform. Once the data is available on the platform, it can be viewed and used with any device. The total station can be used to directly access the data stored in BIM 360. Once a point is selected in the model, it is projected directly onto the designated location using a laser. If a laser stakeout is not possible, a prism can be used as an alternative. In land.
So let me stop at that point. I think you understand that we nowadays can use GNSS diggers and dozers. They are already, the diggers are quite often used in landscape and construction companies in Switzerland, and the tachymeters, the robotic stations, are becoming more and more popular, and also in landscape construction. So these the construction industry is using already this equipment. So landscape architects need to prepare the models. So let me cover the topic of data modeling and data management. All over the world, there are architecture projects and there are civil engineering projects with different players being involved, not only architects or civil engineers, but also MEP people, surveyors, etc. And we as landscape architects are involved in both areas, in architecture projects and civil engineering projects, and basically sit between the two chairs. Sometimes we're closer to architecture, sometimes we're closer to civil engineering, depending on the country. And how can we deal with this challenge? We need to know about civil engineering software, and we need to know about architecture software. And in my opinion, we only can do BIM for BIM construction landscape architecture if we can handle both software worlds. So that's what I'm teaching in Rapperswil at my university. Our students learn to deal with civil engineering software and with architecture software. Also, the common data environment becomes more and more important. We need to send the data on the cloud, on a construction cloud, in order that the machines or the robotic instruments can work, can stake out our design. What is the challenge? You need to teach students both worlds, but that's also our chance to link the architectural twin and the civil engineering twin. I'm not talking about one twin, I'm talking about 2 or 3 twins together. That's, I think, the big opportunity we as landscape architects have, as the civil engineers don't know too much about the architecture BIM world, and vice versa the same. In order to provide landscape BIM models, we need trees. We have a project with 2 other colleagues, and what is our biggest interest? We need trees with tree bales, because we need to control the clashes between the pipes, between all the infrastructure elements and the trees. Also, I'm working together with a commercial provider of drainage gutter, manholes, because we need this type of information, and we need to put it in our landscape designs. I will do a live demo at the end, so let me jump quickly to the presentations. Enscape 3D we're using for virtual reality. This image has historic value because that was the first time I used it, and I immediately discovered a lot of mistakes in my model. And the colleagues at Tsinghua University in Beijing, they had a good time me finding all the mistakes. Really interesting developments. The wild, keep the wild under control. This is a company Autodesk bought and should work towards immersive environments on the cloud-based. So let me go in an outlook. We are now able to combine architecture and civil engineering models. We can put all our piping in these models, all our trees. We can deal with precise surfaces in order to do our drainage design. This is the state of the art. And this image at the bottom explains it in detail. You have the manhole and the pipe going in the retention area. And so what are the next steps? The next steps are definitely going towards data analysis, combining or bridging the gap between BIM construction modeling and stormwater numeric modeling. I think this will be interesting to combine both worlds with each other. And the other challenge is to put all the data again into a GIS. So this data can be the BIM data, all this information can be managed in long term. So the linkage to GIS after the BIM construction will be a challenge, a very interesting topic. I'm almost, basically, I'm finished with my PowerPoint presentation, and I want to give you two live demos. So let me go out of my presentation mode. Nano, you have to 7:42. How much time do you still have?
4 minutes. But
okay, good. will be sufficient. So please have a look. I'm on the cloud. I'm on the construction cloud. This is a student project. On the construction cloud, you see a digital terrain model. You can look from all sides to it, and let's make a section, and let's move in. And we're talking about terrain modeling. So this is the most important section. So I have all my grading done. I have the surfaces done, and so you see all this information. You see also my grading not only exists of the surface, but also of the subsurface information. And most important in terms of rainwater, all this water from the rooftop, from the terrain, from my surfaces ends up in swales in my terrain. And also keep in mind, I want to plant trees. They should live also in my project longer. So I have the tree bales and can analyze it in terms of clashes between the trees and the substructures, which happening very often. So this is the construction cloud, very important to jump into this topic. And another topic I think has a big potential. This is called, you see Civil 3D, and there's a new tool out there is called grading optimization. You see a building platform, you see a swale, and now let's do grading by the machine. So I click on optimize, and the program itself is doing the grading optimization. And I'm pretty sure if Adolphe Alphand, the French civil engineer who did a lot of projects in the 19th century for Haussmann in Paris, I think if he would be alive now, he would be doing grading optimization. I'm sure about that. So thank you very much for listening to my presentation, watching my presentation, and yeah, I'm ready for the discussion.
Thank you so much, Peter. Thank you. That's fabulous. Yes, I'm sure Alphonse would be using the grading optimization tool. So if we could hear from the lovely Thomas Chapman. So Thomas comes from the Rhino side of developing tools. So this conversation has started getting very global about sort of the kind of a number of different approaches that are possible for dealing with a bunch of terrain modelling things. Thank you, Thomas.
Thank you, Nene. So yeah, I've got probably a shorter presentation, and in way of introducing myself, I'm is this? Yeah, there we go. My name is Thomas Chapman. I'm a computational designer. I'm a landscape architect, and I run a little open source project called Landactyls. So, oh, there we go. So why does Landactyls exist? Why do I develop Rhino and Grasshopper plugins? Why don't I just use the standard BIM tools that are out there at the moment? And the answer is really the way the software industry is constructed at the moment. So Rhino, Revit, Autodesk in general, and Nemetschek, Vectorworks, they're all based on a business model called horizontal SaaS, which is software as a service. And what this means is that these software is really targeted at as many professionals as they can possibly get. What this means for them is that they have a really great and large customer base, which means they have a better ability to sell software. What this means for us as professionals, and especially as landscape architects, as we're a small field, we are quite disadvantaged because we basically have to use the software that we're given. We don't have a choice. And this is an issue that I've, as a landscape architect, struggled with my entire career. And it's gotten to a point where I just couldn't be bothered anymore. So I started building my own tools. So that is called vertical SaaS. So that's vertically integrated software as a service. So I'm quite well primed to do this because I'm both a landscape architect as well as a software developer. And what this means for me is I make less money, but it's greater impact for landscape architects, which is important to me because I'm a landscape architect. So how does this all fold into digital terrain? Well, as Peter pointed out, at the moment, really, to do digital terrain, you have to learn both civil software and architectural software, neither of which was ever created for us. So for us to actually start tackling the problem of what we need for digital terrain as landscape architects and as designers, not as civil engineers, I have started to break down what these things are, because these are really well-trodden things. The video game industry, the civil industry, they've all worked this out and built their own tools in the past. So I'm just kind of retreading what they've already done. So what is a digital terrain, right? It's a point in space. That's the essence of it. And then that essence can be multiplied in complexity and detail by adding a point cloud. So a point cloud is just many points in space. And these are describing known features. And this, for me, is a really key word when I am trying to think about developing tools, because when I develop tools, I inherent some risk in other professionals using these tools. So I need to understand fundamentally what these tools are creating and what are known and what are unknowns. So these are known features, and that's going to be quite important. We start to mix in other known features to a greater and lesser degree. So these might be contours, there might be break lines. Break lines are like features like manhole covers and road curbs and things. And also additional spot heights, so future spot heights maybe. The reason we start to abstract these things is because computers have limits. They can't represent a one-to-one ground truth of any terrain. They have to abstract it. So this is the kind of this idea of what is known and what is unknown. And what is unknown is filled in with something called a Delaney triangulation. So this is a really standard algorithm, really tried and tested. But basically what this is doing is taking all that information that you've plugged into this kind of field of known data and coloring in the bits in between. And when you put it all together, you get a digital terrain. So this is, as I said, this is really guesstimating and estimating the ground truth of that terrain. And I think for me personally, this was very liberating to realize, because I'm trying to develop something that is going against the grain, perhaps, of the established civil paradigms. But all their programs are doing are creating an estimation of the truth. So what this really allows me to do, and landscape architects to do, is realize that we don't have to have these very strict programs about what we can and can't do. What we can do is have something that's more aligned to landscape architects, which is needing a way to quickly take revisions and quickly and easily make changes to a landscape that doesn't require a huge amount of technical know-how, and is more focused on the design and understanding of ecology. So that's all. That's all well and good. I think understanding that these landscapes, these digital terrains, are just approximations is really helpful. But what I'm really interested in is taking it further than that, because that's already been done. What I'm interested in is this flow of information between the human and the machine. And this was actually mentioned in the previous presentation, which I thought was really interesting, about AI and our loss of agency. I'm all about agency. I'm all about understanding that the computer is a really good calculator and a good handler of complexity, and we're really great designers, and understanding the fuzzy logic between the rights and the wrongs. So that's what a lot of my tools are designed for from the ground up, is just taking huge complexity and distilling it down to the most simple points, basically, in space to create landscape. Because at the end of the day, I don't create these tools for myself. Well, I do. But I also create them for people who have never used or aren't computational designers. They're landscape architects. They don't want to have a year of onboarding and learning to know how to make a hill, right? So I really see my work as a translation service. So here you just, on the left, you have a raw tin. A tin is a civil engineering term for a triangulated irregular network, which is a fancy word for a Delaney mesh. And then on the right, you have an abstraction of that information. You're starting to pull out Z heights. You're starting to pull out contours. You're starting to realize what's real and what's kind of So I guess what's important to me personally is that professionals start taking control of their tools. I want to open up the tools and do my own thing. I don't want to be told how to work by some software company that doesn't necessarily represent my interests. I want to build them for us, for landscape architects. And yeah, that's me. Thank you.
Thank you, Thomas. That is, yeah, it's such it's a very dear to my heart subject matter, having taught in this area for 12 years or something. It's kind of, I'm looking at it at the moment as this thing that has opened up to so many places. I guess with I did have a set of questions that I wanted to ask, and I'm looking at this iPad thing here in front of me, which apparently you can ask questions to it, and I can translate these questions for you. But my questions changed between your presentations, I think. My first question was, what does digital terrain modelling offer landscape practice? Because I think, first of all, what Peter you're showing is it's such a fundamental deep dive into very hard-hitting tools that do have a lot of responsibility behind them, a lot of legal responsibility that I feel a little terrified of. And where do we fit ideation and responsibility? Peter, did you want to talk to that first? Is that?
I didn't quite understand the term ideation. What does that mean?
Probably specific to Melbourne University. So how do we test multiple ideas quickly? Ideation being kind of a sort of a weird variation on idea testing.
Okay.
Yeah. Alongside this kind of very heavy responsibility that comes with doing a more technically correct job of doing the civil engineering. That's almost the position we're in.
Shall I answer?
Yes, please.
I think this topic just came up just a couple of days in one of my classes, and I told the students the fastest way to get your ideas visualized, use your sketching pen and do some visual sketching of your ideas. This will be never supplemented by the digital tools. So this will probably stay for the next 100 years. This link between your ideas in your mind and bringing them to paper will be not. Will always stay. The sketching will always stay. In a later stage, you have to transform it. Yeah, that's my opinion. So, get your sketching skills. Exercise your sketching skills and your analog grading.
This is the digital symposium, Peter. Thank you. And Thomas, how do you feel about that kind of that tension, I guess, that tension between ideation, dare I say it?
I mean, just to reply to the sketching, I don't sketch anymore. And I think I agree with Peter that to leap away from drawing to pure computational design flow is a very hard step. And you sort of have to have mastery over programming and parametrics and understanding of your workflows to make that leap. And I don't think that is something that will happen generally for a very long time until programs are created that make that as easy as interacting with paper. In terms of the risk that you take on creating terrain, and as a landscape architect, there is this really hard contention between, and I see it as like a chicken and an egg, right? Because a lot of the time the civil engineer will need you to do the grading first before they touch it. And this has a lot to do with the fact that we are the designers and the creators of this space, and so we need to be able to at least get a good enough representation of that landscape. And for me, the key word there is good enough. So my tools are really, and I make this very clear in everything I do, my tools are there, prioritize speed and ease of use over industry maturity, let's say. It's not Civil 3D. If you are a civil person, then use Civil 3D. But for me, I want to be able to, as Peter said, to create terrain as fast as it would take to sketch. And that's everything I do, basically, is just to try and make my life as easy as possible. And being native to the 3D world is the fastest route, because you have to get there at some point anyway. But yeah, I don't normally say for most people to do that though. Not yet, anyway.
Not yet. Next week.
When my tools are more mature, maybe.
Yeah, that's right. Thank you. So, and just in terms of, I mean, it feels to me that there is this build of a different way of practicing coming for landscape architects. We're becoming a different animal. And so it sort of, it terrifies me that we're still tied to the pen in that way. I'm interested in not being tied to the pen, because even though I do draw, it feels that sometimes when you stick a drawing in front of a bunch of civil engineers or a bunch of people who are modelling from the get-go, that it's just not as powerful an argument. So that sort of, that kind of speed of the parameters is very, I think that's pretty important. I mean, I'm terrified to ask this question as well, but because nothing has happened on this iPad here, I'm going to ask it. But this kind of difference between the sort of the software as a service and a vertical software as a service. And there's kind of, you know, software as the taskmaster and software as the sort of, you know, beautiful but very difficult animal to control. How do you see the future? Like, how do you see this in 5 years' time? What's the 5-10-year vision? And maybe we'll start with you this time, Tom.
Yeah, I think we're living in a really interesting time, not concerning any world events at the moment, just in landscape architecture and in general the AEC industry. That's architecture, engineering, construction. I think what we're seeing is a lot of leading people getting a little bit angry with, I'm not going to say the companies, just the big players, about how slow they're moving, basically, and how much of a closed garden that they're creating. What a lot of people want to see in the future is BIM that is free and open source. It's not living in any kind of garden. It lives in a file server somewhere, as Peter was showing, that kind of online web viewer. There's a lot of companies doing that now. One's called Speckle and another, I think, is called Cove Tool. So there's a lot of like tech disruption just burgeoning in the background. And I think that's going to become a big deal moving forward in the next few years. And I think people are it's less going to be about that horizontal SAS and more about each profession having its own vertical program that they use to create their data, because that's all this is. It's just data, and piping that to a open source standardized structural model that everyone can access in their own way. And I think that's probably the direction that things are going.
Mm-hmm. And Peter, do you have I noticed that you have QGIS sitting in your ecosystem of software, which I think its kind of arrival on the scene really pushed ArcGIS's development development trajectory at a much faster pace as soon as it arrived. So do you have something? What's your kind of take on this?
Yeah, I really think I only can talk about Switzerland, but we as landscape architects have to move ahead. We have to push our abilities to cooperate in this BIM environment. We are not doing something on our own. Our projects are always part of a infrastructure or architecture environment. The landscape architects in Switzerland, they are really nervous about this development, that all the projects, the public projects now will follow the BIM process. So we not even have time to think, we have to act. And we also have to act in terms of the climate changes, and we have to put our interests in these digital twins, meaning we need to plant our trees so they can survive longer time, and we need to take care of all the rainwater, the storm, the more happening storm events. So we need to take care of this topic, and so I definitely believe also in Open BIM, IFC, Building Smart are very important organizations to push this topic. I think there's no time any longer for us. We need to act, and so that's what's happening in Switzerland.
I think you're right. I've just got a very fun question here from someone, which it may be a FUM student, I'm not sure. No, maybe. But how do world-building digital tools fit into this conversation on ideation, visualization versus execution? So thinking of Unreal Engine 5 software in particular, which we all want to play with, whoever asked that question. So I think that is another interesting object that sits in there, particularly since Unreal Engine 5 now has that capacity to dig, and also sort of fits into that I'm sure we've all watched the video of the Unreal Engine 5 world building landscape architecture as a game. I'm going to throw that one to you guys, because I don't want to answer it, because I think it's probably just not going to be, at this point, it's too fun. But
no, fun. What we do is fun, and sorry, I think if we can find methods of making our work more fun, I'm all for that, 100%. That comes with like the knowledge that we are still professionals and we have legal and responsible professional responsibilities to the public. But in terms of like the video game industry and landscape architecture, or the AEC industry merging, that is actually happening. we have things like Enscape, as Peter pointed out, which is a real-time rendering engine, which my company uses as well. It's fantastic. It's just been bought by Chaos, which does V-Ray. That system has completely changed how we work in our office. It has speeded up our workflow and really shifted us to a fully 3D workflow, which has been fantastic. We can pump out hundreds of views, doesn't matter. There's no more collaging. And I know a lot of people are going to be sad about that. When you have a deadline, that goes out the window and you want stuff out. So Enscape has been fantastic, and real-time rendering is definitely already here in the industry in terms of like having an engine that having an entire design toolkit inside a video game engine. That's pretty cool. But you know, at the end of the day, I work as a landscape architect. I need stuff that actually works. I can't speculate. I need stuff now. So yeah, no, it's already emerging. So yeah, that's sort of my perspective.
Did you have a take on that one, Peter?
Yeah, I think virtual reality headsets are already arrived in our field, and there it's not only to visualize, it's also to control your construction. We're talking about grading. It's amazing when you're able to walk in your own design terrain, your pathways, roadways, parking spaces, and you can control your grading by this way. I think this is very important to control your technical construction and make sure that your design works. So virtual reality is already there, and the new thing, or what I'm interested in, is this collaboration via construction clouds and via virtual reality. I haven't tried that yet, and I'm curious how it would be to work together with you two guys on a project with students and using virtual reality and headsets to communicate, discuss design or construction.
That sounds really fun. And we've got the entire tech lab in the audience who will also be, I'm sure, very interested in being part of that project, and some landscape architecture students here. So yes, that would be fabulous. We will hold you to that one, Peter.
The other thing with VR, the thing that really blew my mind for VR is sense of scale, and that's something you really don't get on a 2D screen. When the first Oculus Quest came out, I did an entire competition in VR using the kind of 3D painting. So fun, so good, and I really hope that those tools mature. And even if it stays just a viewing platform for the now, the sense of scale is amazing, and that puts a whole new dimension in the way we design. So if you've never used VR to look at your designs, totally try it out. It's super cool.
Don't fall over though.
No, don't fall over.
I think the only thing, so we've probably got time for one more question, which is, I just probably lack the imagination to be able to see this happening. But I was just thinking about the last, one of the last presenters, and I can't remember the name of the tool, but you can sort of sketch in a landscape and it'll give you back a 3D render now. And for me, I'm still trying to imagine how you could sketch in landscape, technical landscape drawings, and for it to turn into something. I'm just personally struggling to see how AI or machine learning is going to change what we do. Go.
Yeah, it's a subject I've been thinking a lot about, because there's a lot of interest in AI, and obviously that's part of my job description, is to try and keep on the forefront of these things. The thing is that AI fundamentally is a way to find an algorithm for an algorithm that you don't know. So if that makes sense, so say you want to calculate 2 + 2, but you don't know the algorithm, but you know the answer, which is 4. You create an AI that finds the algorithm, but it finds it kind of. And for me, so it might get 4 or 4.3, 4.1. There will be a plus or minus accuracy there. And for me, as a professional, I can't deal with that ambiguity. I need assurance about what is happening in that algorithm, and that's why I write traditional software. Because I wrote it, I know exactly what it's doing. But AI is a black box. You can train it, and you can curate the things that go in it to stylize the things that come out of it. And that has all of its other issues with, garbage in, garbage out, that sort of thing. Yeah, but at the moment, I totally agree with you. I really struggle to see the use for it at the moment. But in the future, it'll be, and I sincerely hope it will be a tool for the creation of greater things rather than the thing that creates the thing.
Oh, that would be a sad moment. No,
I think so. Yeah. And it would put me out of a
put
job.
us all out of the best bits of our jobs. That's the biggest.
But I think the best stuff happens when we work together with machines, and that's what I've found so far in my career. Is having that team up.
Yeah, absolutely. So, and Peter, have you had a go with the AIs and you've had to go with the dolly?
Our university is trying to push every department to include an AI course in the bachelor programs. So we are required to offer one course to our students. But we just had the discussion among the faculty that probably a bachelor program is too early to include it. It's more a topic of a master program in landscape architecture. So right now we are a little bit boycotting this course. We are not telling the students to take part in an AI course. That's the discussion among my faculty, and I think it's a topic we have to deal with. We have to look at it, but I don't yet see it in terms of our practical work. In plant for plant identification, there are apps out there using AI algorithms. This is an interesting area. I don't see it for topography yet, but I'm curious and watching it, but I have to deal with all the other aspects. So let my successor deal with this topic.
That's cruel, Peter, I think.
Yeah.
Yes. Okay. Well, I think that's it for us, isn't it? 4:15. So I think that's where we're out of time. But thank you to both Peter and to Thomas for your. It's just been such a wonderful thing personally to have this conversation with both of you. You're both very much on my mind often. So yes. So thank you for making the time today. It was really great to have you here.
Wonderful. Thank you.
Thank you.
Thank you very much for a very exciting session. So just reminding you that up next we have strategies for innovation through research here in the Singapore Theatre at 4:45, and digital world building, digital social spaces that will commence in the Malaysian Theatre also at 4:45. And as always, we appreciate your patience as we reset the room and dial in the next online speakers. Thank you very much.